Hey, glad you came back after the way I wrapped up that last video. Didn't mean to scare you too much, just a little different and a little more complex here. I'm also introducing you to a routing concept you may not have seen yet, so there's a lot going on in this section. What I'm going to do is we're going to walk through a small part of it, and then we'll actually do it on the live equipment. Now, so far we've used physical serial interfaces for our frame relay networks. And using a physical serial interface on occasion can lead to some routing complications, particularly at the hub router. And one of these complications is split horizon. Now with OSPF, there is no problem with split horizon, and you'll see why when we are in the OSPF section. Now with EIGRP, which I'm going to actually configure in this lab, split horizon can be a little bit of a problem. I know you haven't hit EIGRP in this course yet. You don't need any advanced knowledge or know how to configure it in order to understand this lab, because we're going to be watching what happens to a route as it is advertised or not advertised. And what we've got here is a route update going from from router 2 to router 1's serial 0 interface. It's a route update. And the three routers are all using their physical interfaces for frame relay. They're all running EIGRP on the same physical interface. And router 2 is advertising its loopback address via EIGRP. That's the only network it's advertising. And here you can see I ran show IP route EIGRP, and here's the entry. So router 1 is getting that entry. But when I ran that same command on router 3, it doesn't have the route. I ran show IP route EIGRP, and all it did was drop me to the next line. And as I say, but hate to say sometimes, when a show command doesn't show you anything, it has nothing to show you. R3 doesn't have that route, and you would certainly think that it would. Now, router 3, the reason it doesn't have that is a feature called split horizon. This is a routing loop prevention feature. It prevents a router from advertising a route back out the same interface that would be used by that same router as an exit interface to reach that route. And that's one of the things, first time you hear it, you just go, what? I understand. As I've always put it, a router can't advertise a route out the same interface that it used to learn about that route in the first place. And here is router 1's entry for that particular route. And at the very end of all this stuff, all of which we'll see in the EIGRP section, serial 0 is listed. That's the local router exit interface. It's going out that interface. So since R1 would send packets out serial 0 to reach the next hop address to get to the 2222 network, it can't send advertisements for that route out the same interface. See, it makes a lot more sense when you see it in a picture. And that's exactly what it is. It gets the route update on serial 0. It's going to use serial 0 as the exit interface to get to that network. Therefore, it can't advertise that route back out serial 0. So right now, there's no way for router 3 to get it. Well, this leaves us in a bit of a problem here because we have three solutions to that issue. We could create a logical full mesh between all of our routers. We could use the interface level command no IP split horizon to do something about it, or we could use multi-point and or point-to-point subinterfaces. Now with three solutions, you just know there's got to be a problem with at least two of them, or a bit of a shortcoming anyway. Well, we already know the deal with a logical full mesh. If we had a 3-router network like we've got here in a production network, that wouldn't be too bad, but we don't have too many production networks that are only made up of 3 routers. So as you add dozens or hundreds of routers to this, you would quickly understand that a logical full mesh is just not a scalable solution. The second solution, disabling split horizon, it's simple enough in theory. And I've got it here on the board for you. We do that at the interface level in an EIGRP config with the no IP split horizon EIGRP command. And you see I've got a 100 there. That's the autonomous system number for that EIGRP config. If you don't know what that is, you will by the end of the course. As a result, R1 advertises the missing route to router 3, and it appears in router 3's routing table. And just say, hey, that was easy. All I did was disable this routing loop prevention feature, and everything's just fine. Well, split horizon is enabled by default for a reason. It's just like the STP timers. Yeah, on occasion, life would be easier if you just said, you know what, let's just set all those to 0, which of course the switch won't let you do, and there's a reason the switch won't let you do that. Well, even though you might get the route advertisement that you do want after disabling it, you look at this and you say, hey, I got my route, no big deal, man, I'm the greatest. Well, you might be the greatest, but the problem is in the next couple of minutes, you might have other route issues introduced in your network you didn't have a few minutes ago. And whenever something pops up like that, you always look at the last thing you did because that's probably what caused it. And in this case, disabling split horizon could lead to some really serious routing loops. So should you ever disable split horizon in a production network, and I'm not going to say it's never been done, but just be ready. If you have some unexpected routing issues pop up, I would put it back on personally. Now, using interfaces is really a better solution because what happens is these sub-interfaces are seen by split horizon as totally separate interfaces. So that is a really good deal. So if you work sub-interfaces correctly, they're going to be seen again as totally separate interfaces, and you're going to get away with it. Split horizon won't be an issue. It also gives us a great chance to practice using sub-interfaces, which is fantastic. And I'm also going to use this particular lab upcoming to introduce you to the frame interface delc command, because the router is going to be kind enough to tell you when you can and can't use that command, but we all know the exam is not going to be that kind. So when you come back after this theory wraps up in about 5 seconds, we'll jump right into the lab on the next video. See you there.